This is a solution for the mock exam for kinematics. So number one, the following diagram shows graphs of the displacement, velocity, and acceleration of a moving object as a function of time t. Complete the following table by noting which graphs A, B, or C correspond to each function. There's a few different ways to do this. So I'll go through really quickly all three, and then you could see which one makes the most sense to you. First of all, when you take derivatives of polynomials, you straighten the curve a little bit by little bit. Remember in the investigation for differentiation that we first did, we took the derivative of a parabola, or we took the derivative of a parabola, and when we took the derivative of the parabola, we found out that the derivative was a line, right? And if you take the derivative of a cubic, and you find out that the derivative of a cubic is a parabola. So as you take derivatives, the curvy curves become less and less curvy and more straight. So when you look at these, you can see that this is the most curvy and this is the straightest. So this must be the integral of this, or like if you're taking derivatives, if I take the derivative of A, it should become C. If I take the derivative of C, it should become B, which means that the displacement would be the straightest, and the the displacement would be the curviest, and the acceleration would be the straightest. And so this middle one would be velocity. So displacement should be the curviest one, which is A. And acceleration should be the straightest one, which would be B. Okay? Let's look at this a couple other different ways. Let's look at it from the point of view of the 0 points. Okay, so let's look at the 0 points here. The 0 point of the straight line is there. The 0 point of the quadratics are here and here. Now, if you look at the 0 points, they kind of correspond to the maximum minimums of other curves, right? So the 0 point for graph C is the maximum point of graph A, which means that the slope at this point is flat, so that must mean that graph C is the derivative of graph A, because at this flat place the slope is 0, so graph C is 0. So graph C is the derivative of graph A. And then if we look here, we see that the flat part of graph C maps to the 0 point of graph B, which also would indicate that graph C, or if you take the derivative of graph C, you get graph B, which again means that graph A is the displacement and graph B is the acceleration. Okay? Let's look at it one more way. Let's look at it looking at slopes. So if the let's look at where graphs are positive and where they're negative. So if I look at the positive parts of the line, it's here. If I look at the positive parts of the cubic, it's here. And if I look at the positive parts of the parabola, it's here. Okay, so does the positive part of the quadratic correspond to any other graph going up? And yes, it does. Do you see how the positive parts of graph C correspond to the part of graph A where graph A is increasing? So that means that graph C is the slope of graph A, which means that graph C is the derivative of graph A. Okay, and then if you look at the part of graph B, which is positive above the x-axis, it corresponds to the part of graph C which is increasing. So that is also an indication that graph B is a derivative of graph C. So again, graph B is the derivative of graph A, which means that graph B is the acceleration and graph A is the displacement. Okay, so those are three different ways you can look at it. Okay, the first way, where we look at them as polynomials, is not the ideal way because it only works for polynomials. Okay, so if you have other kinds of curves, that method is not going to work. All right? All right, let's look at the next part. B, write down the value of t when velocity is the greatest. Okay, so write down the value of t when velocity is greatest. So now that we know the velocity is graph C, let's just get rid of these. Okay, so we know that graph C is the velocity. So it says, write down the value of t when velocity is greatest. Velocity is greatest at the max point. So the value of t that corresponds to that is 3. So t equals 3. Okay? All right. Next problem. As we talked about in the last problem, one of the things that you have to remember, which I don't think is really that hard to remember if you spend some time reflecting on it, is that the derivative of the displacement is velocity and the derivative of velocity is acceleration. Okay? So, and likewise, the integral of acceleration is velocity and the integral of velocity is displacement. Okay? That's something that you learn for physics too, right? The difference in displacement divided by time, distance divided by time, is velocity. Velocity divided by time is acceleration. Okay? All right. The displacement s meters at time t seconds is given by, and it gives you a function here for s, and it gives you a domain that t is greater than or equal to 0. Write down the minimum value of s. Okay. Okay, this initial part is where you need the calculator to find the exact answer. Okay, so the displacement s meters at time t seconds is given by s equals 5 cosine 3t plus 7.5t plus 10. What's the minimum value for the domain t is greater than or equal to 0? Normally, what you might do without the calculator would be to take the derivative of s and set that equal to 0 and find all the local minimum points and find out which one is the smallest or the least. But remember that if your domain is not all real numbers, and in this case it's cut off at t is greater than or equal to 0, then you do need to compare the boundary points, the edges of the function, with all the local minimums. And because of that, we really need the calculator to see if the boundary points are smaller than the local minimums. Okay, so and that makes this part actually one of the easiest parts of this problem, because all you need to do is you need to be able to use the calculator. So let's graph this function by typing in the function into the y equals screen. And I'm just going to type in 5 cosine 3t plus, before I do that, we do want to make sure that the mode is correct. Whenever you turn on the calculator and you haven't used it yet, or when you reset the calculator, it's in radian mode, which in this case is what you want. Whenever you do trig functions, you want it in radian mode and not in degree mode. So let's go into y equals, and I'm going to type in the function with x's instead of t's, and then I'll be right back. Okay, I just typed it in, and then I graph it. pretty weird function. Let's only graph the x equals 0 part, x is greater than or equal to 0 part. So I'm going to do window, and I'm going to change my x min into 0, and my x max, let's put like, yeah, 10 is fine. And then for the y max, I'm going to put something bigger because it was going off the edge of the screen, right? So let's put 25 instead. See if that fits enough of it. Okay, so now this is a really good angle because from this we can see visually that the lowest point on the function is not the edge of the function. It is this first minimum point. So let's find the first minimum point by doing second calc minimum, which is number 3. And then the left bound, we'll just put the cursor. I can't even see the cursor, so I'm going to come back a little bit from the left, see if it's off the screen. Yeah, I think it might be off the edge of the screen. What if I just type 1? Bring it back on the screen. Okay, that was not enough. Do you see? Actually, it's smaller than 1. So let's repeat that. Second calc minimum, and then the left bound, I'm going to move it slightly to the left of the minimum, and then I'll hit enter, and then I move it slightly to the right. This virtual calculator is really bad with my very old touchscreen. And hit enter when it gets to guess, and it will tell us that the minimum is 0. It's t. Let's see. T equals 0.87266. And the displacement is equal to 12.215. And so it's asking us for the value of s, so I'm going to put 12.2 here. Okay? All right. And we know that all the other points are higher because this function steadily increases. If you want to see what it looks like, just do zoom fit, and you can see that the thing has a very nice little pattern. Zoom fit, which it just kind of like goes up and down, but it steadily goes up. Okay, so we know that our minimum point is, or the minimum s value is 12.2. Okay, and then it says find the acceleration a at time t. Now remember, acceleration is two derivatives of displacement. So when you take one derivative, you get velocity, and then when you take the second derivative, you get acceleration. So let's take two derivatives of displacement, and that'll give us the acceleration function. So the first derivative of displacement is 5 negative sine 3t, and then the chain rule of 3t would be 3 plus 7.5, because the derivative of 7.5t is 7.5. Derivative of 10 is 0, so that just disappears. Okay? And that is the velocity. And the acceleration is the second derivative. Okay? So before you find the second derivative, I think this is like one of the times when simplification is important in IB, because before you find the second derivative, if you simplify the first derivative, it's a little bit easier for you. So let's multiply 5 and 3 together, we get 15. So it would be negative 15 sine of 3t plus 7.5. That is our first derivative of s. And then let's find our second derivative of s. It would be negative 15 cosine of 3t times the chain rule 3. And then 7.5, the derivative of 7.5 is 0, so that just disappears. And then if we multiply the 3 and the 5 together, to simplify it, we get negative 45 cosine 3t. So that is the acceleration function. It is negative 45 cosine 3t. Okay? All right, let's go to the last part of this section. Find the value of t when the maximum value of a first occurs. Okay, so there's a couple ways you could do this. One is, this is a calculator problem, so you could just graph this function. So I'm going to just disable the first function, and then I'm going to put my acceleration function here, negative 45 cosine 3t. And then I'm going to graph this, just the second function. And of course it's just it goes up and down like a sinusoidal function. And then it says, what is the value of t when the maximum value of a first occurs? That would be this point right here. So if we wanted to find the t value, we would just do second calc maximum, which is number 4. And then let's put the left bound at about 0.2. Okay, and then we'll put the right bound at about 2. There it is right there. So the t value in this case, is 1.047. And the acceleration value at that point is 45. And we know it's the first point that it occurs because it's the leftmost point, right? If we were doing this without the calculator, you could do it by saying, okay, if it was cosine, then it looks like this, right? And then the maximum points would be here and here. But it is negative 45 cosine blah, 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 which means that the thing is inverted. So instead of having the maximum point here and here, you have the maximum point here. And where is here? Well, it's when the red cosine function has a value of negative 1. The parent function has a value of negative 1 right there, right? So when does cosine 3t have a value of negative 1? So that would happen when, let's see, it would be the triangle at 180 degrees for 3t, right? If it's cosine of 180 degrees, that would be a cosine of negative 1. So that means 3t would equal 180 degrees or pi, right? And then so the t value would be pi divided by 3. And then, pi divided by 3, that's 3.14 divided by 3. Oh yeah, that makes sense. That's why it's 1.047. Okay? So the answer is t equals 1.047, which we got with the calculator. Okay? If you were going to do it without the calculator, then you would go through that process of saying, okay, the cosine function looks like this. The cosine function flipped over, it looks like this. What's the value of 3t, which makes the cosine function minimum? It's pi, etc. Okay? All right. Let's go to the last problem. A particle moves with the velocity v given by v equals 25 minus 4t squared, where t is greater than or equal to 0. The displacement s meters is 10 when t is 3. Find the expression for s in terms of t. Okay, so in this particular case, they're giving us v, and they want us to find s. So remember, normally in derivatives, you start with the s function, and then when you take derivatives, first you get the velocity function, and then finally you get the acceleration function. If you're going to do the integral, you're actually going backwards. So when you take the integral of a gives you v, and the integral of v gives you s. They gave us v, so if we want to find s, that means we need to find the integral of v. So let's find the integral of v to find the s function. So we write out the integral, and when we do the integral of 25 minus 4t squared, the integral of 25 is just 25t. The integral of t squared is t cubed over 3. So, and then we leave the negative 4 in front of it, so it's negative 4t cubed over 3. And we've just taken the integral, so we get this function plus c. Okay? And that would be the displacement function as a function of t. Now, it does tell us that the displacement of s is 10 when t equals 3. Those are boundary conditions which you can use to figure out what the c value is. So let's put 3 in for t here and for t here, and then we put in 10 for s, and then we'll see what the value of c should be in that case. So it's 25 times 3 minus 4 times, and t cubed would be 3 cubed is 27 divided by 3 is 9, so 4 times 9 plus c, so that is equal to 10 equals 75 minus 36 plus c, so that's equal to 10 equals 75 minus 36 is like, I think 39 maybe, plus c, so c is equal to negative 29. Okay, so in the end, our function is equal to 25t minus 4t cubed over 3 minus 29. Okay? All right. Part B. Find t when s reaches its maximum value. Okay. Find t when s reaches its maximum value. You could do this without the calculator, but since this is a calculator problem, let me show you how to do it with the calculator first, and then we'll talk about how you could do this without the calculator. So first thing you want to do is you want to put the function into y equals so that we can graph it, and then we just want to see when it reaches its maximum value, kind of like what we did last time, except last time we were looking at the minimum value, right? So 25x, we just put x's instead of t's, and then we're going to put 4/3 t cubed, which would be x cubed, and then we're going to put minus 29. Okay, and then we're going to graph. Let me change the scale here. So we'll do zoom fit. I think it's got to finish graphing before I can do zoom fit. Zoom fit is zoom 0. Oh, that's a really weird graph. Okay, maybe that's not a really good range. So let me change the window. I'm going to change, look at that. The y min, I'm going to make it like negative 20. And the y max, I'm going to make it positive 20. Okay. All right. So it says find out when s reaches its maximum value. It would be that point right about there. So let's do second calc maximum, which is number 4, and the left bound, I don't know where the cursor is. Oh, I think it's too high, so I'm going to put like 1, and then the right bound we can put like 4. Okay, and then we hit enter for guess, and the maximum point is 2.49999, which would be 2.50. Right? So I'm going to say that the t value is 2.50 when s reaches its maximum value. Apparently the s maximum value is 12.67, right? Now, if you wanted to do this by hand, how would you do it? Well, basically, we need to find when the derivative of the s function is equal to 0, because that's where the maximum point is. So, and we happen to know the derivative of the s function. It's 25 minus 4t squared. So we we find that function and we set it equal to 0, and then we solve for t. which in the end, you're going to get like a function which you can solve without the calculator. But this was a lot easier, right? Okay, you didn't even have to take the derivative. So on the IB exam, don't do it the non-calculator way. If you're on paper 2, right? Save time. Do it with paper. Do it with the calculator. Okay, let's go to part C. The particle has a positive displacement for t between m and n. Find the values of m and the value of n. So we're looking at the displacement function right here. And so it's saying, when is the displacement positive? So that would be where this little bump surges above the x-axis, right? And to find those points, we could use second calc 0, right? If we do second calc 0, we can, and then we do left bound, we put the cursor slightly to the left, so that would be, we could put 0.5. Oops. Didn't like that. Let's graph again. Second calc 0, which is 2. And then it asks for left bound, I'm going to put 1. And then it asks me for the right bound, I'm going to put 2. And I hit enter for guess. And the first 0 value is 1.2689, blah, blah, blah. So I'm going to put 1.27, if I round correctly. So 1.27 is the first place it crosses 0. And the second place it crosses 0 is second calc 0. And then the left bound we could put like 3. And the right bound we could put like 4. And it tells me that, oh, and then I do guess. And the second 0 point is 3.55. Okay? Alright, so between the x value of 1.27 and 3.55, it goes above the x-axis, which is when it has positive displacement. So the value of m would be 1.27, and the value of n would be 3.55. So let me write that here. M equals 1.27. N equals 3.55. Because those are the x values where the bump goes above the x-axis. Okay? Now, how could you do this without the calculator? I don't think you could. Okay? The way we find roots of cubics, which is basically what you're doing here is you're finding the root of a cubic function, we use synthetic division, right? And, what's it called, synthetic division? I forgot what it's called. But we use that process that we learned in 10th grade, and these don't have integer roots, so it would be a big mess. I don't know if it would be possible. I don't think it would. So, so in the end, you have to use a calculator anyway for this. So that is why this would be a paper 2 problem. Okay?